Hello everyone, welcome to the Go Code Snippets channel. This channel is all about the Go programming language, and today we'll be talking about dealing with matrices, implementing matrices in Go. So, if you're new to the channel, make sure you subscribe and also hit the notification bell so when I release new videos, you'll be the first to be notified. So, without further ado, let's go. So, the first one we're doing is we'll be defining our matrix struct. So, our matrix struct will be having just one field, which is the dimension field. So, a dimension field will be a bi-dimensional slice. So the reason is because this first slice here represents each row and the second slice here represents the column. So if we're having a matrix n by n, or let's say a matrix of 2 by 3, so our dimension will look something like this. So we're having a slice of slice. So we're having a slice of slice. So we said 2 by 3, that is two rows, 1 and 2. Then three columns. So we're having like A, B, C, then D, E, F. So this is how our matrix will look like. That's why it's actually a bi-dimensional slice. So the first slice represents the row, second one represents the column. So the first thing we'll now be looking at is a functioning matrix. So functioning matrix just creates a matrix with all its values set to zero. That is a zero matrix. So to do that, it takes into arguments, which is the number of rows we want and number of columns, and it returns the matrix for us. So the first thing we first check for is this, to check if the number of row is zero or the number of column is zero, because you can't have a zero by zero matrix. At least the matrix should have at least one row in case of a row matrix, or one column in case of a column matrix. So that is that for that. So if either of the two is zero, we just return, we will log to standard outputs error main row and column length, which is one of the global variables I defined here to be used as error strings. So this is it here, error main, this particular error here, this is it here. So then we return a matrix with no dimension, an empty struct of matrix. That's what we do. Else, if that is not the case, we'll create a dimension. We initialize the dimension for the new matrix we want to create. Then we'll range over the row number. So from 0 to a number before the row number, then we'll increment, then we'll create, for each of that we'll create a column. So what we're doing here is that we are first initializing our, so at this point we are initializing our slice, that is this point here. Then for here, for each time we have a row, like I said earlier, that the matrix is going to have, if it's a 2 by 3 like we did earlier up, we'll have two different slices. Then inside each of them, the column will determine the number of elements that will be inside each slice. So in this case, let's say that we are putting 3 here and 3 here as our row and column number. So what we just have is first create a bi-dimensional slice. Then we'll be having, for each row number, or for each time that there's a row, we'll create a new slice. That's what we'll do. For each time there's a row, we'll create a new slice. That is what we are doing here. We'll create a column, which is this. Then we'll append to the column 0 as the values for the amount of times we have a column. So if you have a column, like our column number is 3, so we'll be having 3 zeros for each of them. So that's what we are basically doing here. So we just range from 0 to the row number. Then for each time we have a row, we'll just create a column, and we'll also range from 0 to the column number. Then we'll append 0 to this column we're having. So that's it. So this here is going to be like a 2 by 3 matrix. If it's a 3 by 3 matrix, it will be an extra row. Then we'll be having 0, 0, 0. So that is how this particular block of code works. So we'll create a column, then we'll range through the column number. For each time we have a column, we'll add 0 to the column. Then we'll now append the column to this dimension we created up here. Move this down so we can have more space. So that is it. Then we'll return a matrix with the dimension set to this. So that is what the functional matrix does. Then the next thing we'll be looking at is a print method. So the print method will just range over the dimension and to print out each row. So let us test those two and see what we get. So I'll come to my func main. So I've actually created them down to make the video shorter. So I created two matrices. So there's one thing I also want us to note, that the matrix positioning starts from 0 to a number before the row and also a number before the column. So if you have a 2 by 3 matrix, for example, in this case, this one here will be position 0, position 1, position 2, then position 0, position 1, position 2. So this one is the index will be 0, index will be 1, index will be 2, 0, 1, 2. And also for the rows also, this itself, the whole thing here, this here is 0, then this here is 1, and this here is 2. So that's also one thing I need us to note. So I'll be creating two new matrices. I'll be printing out their result as what we have. So the first one I'll be creating is I'll be creating a, or let me create one. So first I'll be creating a 2 by 2, a 2 by 3 matrix. So I'll comment this, then I'll print it. Then maybe I should create a second one also, then we can print it. Let me make this one a 4 by 3 matrix. Then I can just print it also. And we'll see what we have. So let's see what we have. So I'll print it out in my console. And also one more thing, so we'll know that there are two different matrices. Let me comment this also. So to separate the matrices. So we'll run the code and see what we have. I have an error on line 33. What have I done wrong? Oh, this. So there we have it. We have our two matrices. One is a, so our two matrices. The first one is a 2 by 3 matrix. That's two rows and three columns. So we have two rows, one, two, and three columns, one, two, three. And the second one is a 4 by 3 matrix. That is four rows and three columns. So having one, two, three, four, four rows and one, two, three, three columns. So that is the first thing. That is how the function new matrix works. So I'll comment this out back, or let me leave it and change it back to 2. So the next thing next we'll be looking at now is after we've seen function print. So the next thing we'll be looking at is function set. So the set method rather. So what the set method just does is just takes in the position, sets the value of a particular element in the matrix to a given value. So it takes in three arguments: the row position, the column position, and the particular value we want to set. So the row position is just the particular place in the row we want to check, and the particular place in the column then to set it to this value. So what we just simply do is just take m into of dimension to look for the row, and from this look for the column, then to set that particular element to the value, which is the third argument that we're passing into set. So that is how set works. And like I said, the position starts from 0 to a number less than the row, and also 0 to a number less than the column. So for this case now, where we have a 2 by 3 matrix, that means we'll be having the first row to be position 0, and the second row to be position 1. Then the three columns, the first column will be position 0, second column position 1, and third column position 2. So that is it. So let us just set, let me comment this out. Let me just perform the operation on matrix 1 only. So I can just say m1 dot sets. So I'm setting, so in this case I'm setting row 1 column 1, and I'm setting the value to 4. So initially it was 0 because we're having a 0 matrix when it was being created. So the value of the elements in the position of row 1 column 1 will be set to 4, then row 1 column 2 set to -3, then row 1 column 3 will be set to 5, then row 2 column 1 will be set to -2. So let us print that and see what we get. First number. So that is it here. So we're having row 1 column 1 for row 1 column 2 -3, row 1 column 3 5, then row 2 column 1 -2, then row 2 column 2 and row 2 column 3 remain 0 because we didn't set them. So they just remain 0 like we wanted. So that is how the set method works. So the next thing we're looking at now is the add method. So the add method just adds two matrices M1 and M2. So it's a method. So you call it on a matrix, then it will take in another matrix as an argument, and to add the two of them together and return a matrix, which is the sum of the two matrices, and an error if one occurs. So the first thing first we first check is for two matrices to be able to, for you to be able to add two matrices, the first thing you have to first check for is that the row numbers, their rows number and their column numbers are actually equal, or else the addition won't be possible. So for us to do that, we first have to first get the row number, the number of rows and number of columns for each matrix. So for that, I created a upper function called get row and column number. So let us see what that function does. So what function get row and column number does is simply get the number of rows and number of columns for the matrix. So to do that, I'm just initializing the column length variable. So I'm changing over the dimension. Remember that the dimension is a bi-dimensional slice. So the first dimension is the row, second dimension is the column. So that means if I get the length of the dimension itself, that is the row number. So I'm just returning length m dot dimension as the row number, which is the first integer we're having. Then to get the second integer, which is the column number, we'll create a initialize a column length variable and I'll range over a dimension. And I also range over, because if I range over the dimension, I'll be having a slice too, since it's a bidimensional slice. And if I range over it again, I'll be having its value. So from, remember that I starts from 0 to a number before the length of the array. So that means I have to add 1 to get the actual length of the array, which is the column length. So I'll return that as the column length. So I'm returning length and the dimension and also column length. So that is what function get row and column number does. So we'll be using that here in our add function. So I've been getting the row and column of the first matrix, which is this, then row and column of second matrix this. So I'll compare it. That if the rows are not the same thing, the columns are not the same thing, I'm returning an empty matrix. And I also return an error unequal row or column. So which is what I defined here also as a global variable. So I'm having error unequal row or column, which is this here. So that's what we get. Then if they are equal and everything is fine at this point, so we'll just create a new matrix and we'll call it sum. So the new matrix also be having the same row and column. Since here we've already determined for the code to pass this stage, that means the row and the column of the two matrices are the same thing. So and there are some also have the same row and column as two of them. So we'll just create a new matrix with row one and column one, because at this point these two are equal and these two are equal. So I can use any of the two of them to create a new matrix. And remember that the matrix, the sum matrix will also have the same and the same column as the base matrices. So I'll just create a new matrix with a row and a column with the same and the same column as the base matrices. And I'll just range over the row from 0 to a number before the row number, and also range over the column from 0 to a number before the column number. So I'll just set it. So what I'm just doing here is that I'll just set each position of the matrix. So I'll be having as position 0 0, that is row 1 column 1. So I just want the dimensions. I'll just add it to equation. This one's each of the matrices. So I'll just get the value of this one as 0 0, which is this. Then I'll add it to the value of this one as 0 0. This is this. And that will be the value that will be setting into the sum. Because remember that set takes in three arguments: the row position, which is what we have here, the column position, and also the value. So the row position in this at this point is I, the column position is J, and the value is just the sum of the same of the elements in the same position as the two base matrices. So after that, I'll just return the sum and nil, because at this point we don't have any error again. So I'll just return the sum, which is the sum of the matrices, and nil, which is the zero value for an error, because we don't have any error. So let us test that out and see what we get. So for that, I'll uncomment this also. Uncomment this. Then I'll uncomment this. Then I'll uncomment this also. So that's what we have for that. So what I'm just doing is I'm creating two matrices, then I'm setting all the values for the first matrix, then I'm printing it out. Setting all the values for the second matrix, printing it out so we can see what they are before we add them. Then we'll also add them. Then after we add them, we'll assign them to an add variable. Then we'll also print out the matrix add. So let's see what we have. So this is what we have for each matrix before we actually added them. So we have this for the first matrix. This first, I don't know I'm setting the same values to the two of them, but anyways, you can try the you can try setting different values. You surely get the sum. So 4 plus 4 is 8, minus 3 is minus 6, then 5 plus 5 is 10, then minus 2 is minus 4, 0 plus 0 is 0, 0 plus 0 is 0. So you can actually also implement a function subtract, or a function, a method sub, to subtract two matrices. So to do that is also going to basically be written as this function or as this method add. But the only thing you will just be changing is instead of you having a sum, you'll be having a minus here. So that will change the logic of the whole method to subtract from add. So that's why I didn't bother creating a subtract function, or a subtract method rather. I don't know why I keep on saying function, but generally in programming, functions, method, and procedures, those are terms that are interchangeable. Basically they basically have the same meaning most times. But just to like use the right word, to the right word for the right thing. So I guess it should be method, not functions. I don't know why I keep on saying functions. So that is that for that. So the next one will be implementing is the method multiply. So method multiply, just like method add, or method add, also multiplies two matrices and returns a matrix, which is the value of the product of the two matrices. So to do that, first of all, we also first get the row and column number for each matrix, because to multiply two matrices, in this case we are multiplying m by m2. The number of columns that m2 has must be equal to the number of rows that number of columns that m has must be equal to the number of rows that m2 has, for the multiplication to be possible, because that's how matrix multiplication works. That's the first thing we need to take note of. So for that, I'll get the row and column number of each matrices. Then I'll compare the column of the first matrix to the row of the second matrix if they are equal. And if they are not equal, so I'll just return error row not equal column, which is also something I defined up here. So this is it here. So it returns that as an error, and also returns an empty matrix, which is the first argument. So, and if that didn't happen, so we'll create a product which is going to be a new matrix. So the way matrix multiplication works is, if you're having a matrix p times q, and you're multiplying it by a matrix q times c. So what this means is that you are multiplying p times q by q times c. So the first thing that we actually made note of here is make sure that the column equals to the row. So in this part now, this particular matrix, they can be multiplied, because q, which is the column of this, is equals to q, which is the row of this. That's the first thing. Then the product will just simply be a matrix p times c, which is the row of this times the column of this. That is how it works. So I'm just creating a product which is a new matrix, which is the row of the first matrix times the column of the second matrix, which is what we have here. So that is what we have here. So after that, what we just use now. So the way matrix multiplication works, I guess maybe you have to go and check that out yourself. But the way it works is that you multiply the row of there's a way you multiply the row of the first matrix by every column in second matrix. So you do that for each row of the first matrix and each column of the first matrix. So the way that works is that I actually wrote a function for that, which is perform multiplication operation, which is here. So let us quickly check that function out and see what it does. So function perform multiplication operation. So what it does is just simply takes in two arguments, which is the row and the column we want to perform the operation on. They are both slices of int, and returns an integer, which is actually the results that the operation gives. So to do that, what the way it works is the way matches multiplication operation happens on rows and columns is that if you have a row of A, B, and C, and want to multiply it by a column of D, E, and F. So what we'll be having as our multiplication will be A times D plus B times E plus C times F. So that what we'll be having as the result of the multiplication of the row by the column. So it will just be this times this plus this times this plus this times this. So that's how it works. So that's what I'm just simply doing here. So I'm taking in the row and the column which are slices. So this is the row and this is the column. So what I'm just doing is I'm just ranging over, and we've actually made sure that they're actually the same thing from our first operation. So since they are the same thing, you know that their length will be the same. They actually have the same length, so their length will be the same. So I'm just ranging over the row. So this I here will be from 0 to a number before the row, which also be from 0 to a number before the column, since the row and column have the same length. So I'm just creating a sum variable first. I'm initializing a sum variable first. So sum will just be plus or equals to row into bracket I times column into bracket I. So how I'm saying is that row into bracket I will be A, and column into bracket I will be D. So I'm multiplying them together. That is A times D. Then I'm adding them to sum. Yeah, I'm adding them to sum. So I'll be having A times D, I'm adding it to sum. Then see, remember it is plus or equals to, so it will keep on getting added to sum. So we return sum at the end of the operation. So that is how perform multiplication operation works. So that being said, so to now perform the multiplication operation, before we do that, first have to first range. So I'm ranging over the dimension of the first matrix M1 or M. So I'm ranging over the dimension. So this what I'm doing here is just getting the rows, getting each row in the first matrix, in the first matrix. That's the first thing, because to perform the multiplication operation I need each row in the first matrix and each column in the second matrix. So I'm getting each row in the first matrix here. Then to get each column in the second matrix, which we want to do here, first have to first range over the second matrix. So when we range over the second matrix here, this V here will actually be each row in the second matrix, not each column, but we want to get each column. So to get each column, we'll have to first range over the row. So when we range over the row, each element in the row falls in a particular column. So this K here will actually be the index of the column that each element falls in. So we'll now use that particular index to get the column from this matrix M2 using a function get column for matrix. So our function get column for matrix, the way it works, so what our function get column for matrix does is just takes in the matrix we want to get the column from, then the column number we want to get. It's going to return a slice of int, which is the column. So for that, we first initialize a column, which is this. Then we'll now range over the dimension of the matrix. So we are getting each row here. So we want to get each column. So to get each column, so we'll just append to this column variable the particular. So we append to column variable the particular element inside the number that we specified there. So if we want to get column 0 for each row, so we just range over the row. So we just get the first element in each row and we're appending to the columns. That's the column 1. Then if it was to be like the second column we want to get, and we put 1 into this place, because 0 will give us the first column, 1 will give us the second column, 2 will give us the third column, and so on and so forth. So if we put 1 in, that means we want to get the second column. So we just range over the dimension. That means for each row we are getting the element in the second position, which is actually the second column, and we're appending into this column variable. So we just return the column variable. So that is how our get column for matrix works. So we'll be using it in this place to get each column. So we'll now do the sum by performing matrix multiplication operation on the row from this, and the column we got from our matrix M2. So we just perform that operation in, then that will be the sum that we want. So we just set the sum to this product that we got here. So we'll do product that set I, K, and sum. So I is actually the position of the row, then K is the position of the column, then the sum is the value we want to set it to. So that's what we do, and then we'll return the product and we'll return new as our error value, because at this point we're not having any error again. So that's that result. So let us just see that in operation, in action rather, and see what we get. So I'll comment this back out to avoid confusion. So let me comment this out and I'll uncomment this. So when I comment this, so the first thing I'm doing is I'm creating two new matrices. The first one with two rows and two columns, that's a 2 by 2 matrix. Then second one with two rows and three columns, 2 by 3 matrix. So the first thing to take note of that this one has two columns and this one has two rows. So the row and the column is the same thing. So definitely we can multiply them. So I'm just setting the values row 1, column 1. I'm setting the values to 2, row 1, column 2, -1, then row 2, column 1, 1, row 2, column 2, 0. Then for the second one, I'm also doing row 1 column 1 to be 1, row 1 column 2 0, row 1 column 3 1, then row 2 column 1 2, row 2 column 2 4, row 2 column 3 5. So we'll print each of them. That's the first thing, just to see what they look like before we multiply them. Then we'll now multiply them and assign the value to a product variable. Then check if there's an error. Then we'll log fatal if there's an error. Otherwise, we'll just print the product. So let's see what we get. Um, So this is the first matrix. This is what we get. And the second matrix is what we get. And when we do their product, this is what we get. So just to test that, let us see. So the way it works is you multiply the row of the first one by the column of the second one. So what we are doing is 2 times 1 is 2. Minus 1 times 2 is minus 2. Then 2 plus minus 2, that's 2 minus 2, 0. So having 0. Then 2 times 0 is 0. Minus 1 times 4 is minus 4. 0 minus 4 is minus 4. Then we are having 2 times 1 2, minus 1 times 5 minus 5, 2 minus 5 is minus 3. So we do that also with the second column for each row, or for the second row for each column instead. Then we get what is downward. So that is how the multiplication works. So with that, that will be the end. Oh, before I end the video, there's one more thing I would actually like to mention. So if you notice that in our implementation or in our code, we are using the for loop continuously. So if you don't really understand the concept of for loops in Go, I have a video on for loops also on this channel. So you should check it out later to understand the way for loops work. So if you don't have a really good grasp of how for loops work, this might actually be very confusing. And luckily enough in Go, we only have a for loop, so we don't have a while loop or do while loop or for in loop or whatever you have in other languages. It's just a for loop, plain and simple. So you can just check the video out. It's also on this channel. So that's also what I would like to mention. So that's it for this video, everyone. Thanks for watching. If you like the video, please make sure you hit the thumbs up. It really helps me get my content out there. And also, if you're new to the channel, once again, make sure you subscribe and also hit the notification bell. So with that, that will be the end of this video. See you in another video. So